we're going to take a look at the distance formula. Before we get into the formula as it's usually defined, I want to point out that the distance formula is just the common application of the Pythagorean theorem. And I'll show you what I mean here. Distance formula asks you to find the length of a line segment. So here I have drawn a line segment. But it's also very similar to finding the hypotenuse of a right triangle. So for example, since we're on a square coordinate grid, if I go from one end of my line segment and go up to where the x-coordinate of the other one stops, and then draw a line from there up to the other coordinate, I've created myself a right triangle here. I can use that, if I know the lengths of the two sides, to use the Pythagorean theorem to calculate the length of the third side. And so all I need to do in this case is simply count up what I have, since it's drawn on a coordinate plane. So I go 3 units over here, so this side is 3 units long. I go 1, 2, 3, 4 units up, so this side will be 4 units long. So let's go ahead and use the Pythagorean theorem. We know that that means a squared plus b squared, the two shorter sides of my right triangle, is going to be c squared, our hypotenuse. Let's plug in our values of 3 and 4, so we have 3 squared plus 4 squared equals c squared. If we evaluate each of those, 3 squared is 9, 4 squared is 16. Add those together and we get 25. And finally, to solve for c, we take the square root of both sides and we get c is equal to 5. You might be wondering where the plus or minus is, since we're undoing a square. But since we're dealing with distance here, we don't care about negative length. Length is always going to be positive. So in this case, we're only going to keep the positive results of the square root. So finally, we're going to end up with c equals 5, and we can label that on here as the length of our longest side. Now let's take a look at the actual formula. It says the distance between any 2 points, x1, y1, and x2, y2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Very long formula, but all it's saying is how far apart are the x's, square it, how far apart are the y's, square it, and take the square root of the whole thing, which is exactly what the Pythagorean theorem is actually doing. Let's try an example. Find the distance between a and b, given that a is the point 7, 5, and b is the point 12, negative 5. When we're done, we need to make sure that we simplify our root. So I went ahead and found how far apart each of the x values were and how far apart each of the y values were. 7 and 12 are 5 units apart. 5 and negative 5 are 10 units apart. So I just drew a little line between them. If we use the Pythagorean theorem, we know that our x side is 5 units apart. I'm going to reference back to here. What we found was how far apart the x's are. So we looked just at the x coordinates. Then we found how far apart are the y coordinates. So how tall is this side here? And we squared each of those and set it equal to c squared. 25 plus 100 then is going to be c squared, and that's 125 is equal to c squared. Before we go any further, I want to show you what it would be like if we popped it into the formula. So we're going to actually get rid of that. We're going to have our x coordinate for our b, so x2 minus the x coordinate of our a, x1, so 12 minus 7, all that squared. Negative 5 minus 5, all of that squared. So this is going to be 5 squared over here, and this is going to be negative 10 squared over here. If we square each of those, 5 squared is 25, and negative 10 squared is 100. So we're going to end up with c equals the square root of 25 plus 100. Now, both of these different ways of doing it are going to take us to the square root of 125 is equal to c. If you take the root on both sides here, or if you add up what's under the root here, We're going to go to the same place. So it shows that both of these methods will get you to the same answer. You pick the one that you're more comfortable with. Then we need to simplify our root. This is our answer, square root of 25, but we need to simplify our root. So we know that 125 is going to be equal to 25 times 5, and that's 5 squared times 5. And since we have something squared under the root, we can pull that out front and make it 5 roots of 5 is equal to c. We can't simplify that any further.